Welcome once again to another edition of my lesson on the gravitational field. I am Olayiwola Abosede. Welcome. Recall in the last session that we talked about the gravitational force, the gravitational field, and Newton's universal law of gravitation. This is a continuation from the previous lesson. But before we proceed, I will want you to mention two other instances that show the effect of gravitation. Were you able to attempt that? Good. Now today we shall look at the various problems that need solutions using the mathematical expression of Newton's universal law of gravitation, and as well define the gravitational field intensity. Outcomes. So by the end of this lesson, you should be able to solve various problems on gravitational force, and 2, define the gravitational field intensity. Now let us consider this example. A satellite of mass 1 ton orbits the Earth at a height of 4 × 10⁻⁷ meters from the Earth's center. Calculate the gravitational force on the satellite by the Earth. Take G equals 6.7 × 10⁻⁻11 Newton meter square per kilogram square, and the mass of the Earth 6 × 10⁻24 kilograms. Remember what I called the big G? Yes, that is the gravitational constant. So using the mathematical expression of Newton's universal law, which is F is equal to G mm all over r square, we substitute our values. Your big M is equal to the mass of the Earth, which is equal to 6 × 10⁻24 kilograms, and your small m, which is mass of the satellite, which is 1 ton. A ton is 1,000 kilograms. And remember, we have to use the standard unit of mass, which is kilograms. So that is why we are changing our 1 ton to be 1,000 kilograms. Now, if we put in our values, your big G has been given as 6.7 × 10⁻⁻11. Your big M, 6 × 10⁻24. And your small m, 1,000. All over your r. Your r there is the distance between these two masses, the satellite and the Earth. And that is the height there, 4 × 10⁻⁷. Multiplying and dividing, our gravitational force becomes equal to 251 newtons. Please, the unit of your force has to be included. We emphasize our units in physics. We emphasize the units of our quantities. So you have to put the newtons there. Your gravitational force between the satellite and the Earth here is 251 newtons. So this takes us to the gravitational field intensity. This is also called the gravitational field strength, and it is defined as the force per unit mass at any point on the surface of the Earth. It is derived from the formula F is equal to ma, or mg as the case may be, since weight and force have the same unit. So making G the subject of the formula, G is equal to F all over m. The unit according to the formula is Newton per kilogram. Your Newton for force and your kilogram for mass, or meters per second square. Now, if m is the mass of the earth of radius big R, the force it exerts on a body of mass m on its surface is given by F is equal to G mm all over R squared. You're already familiar with that formula. So substituting equation 2 into equation 1 on the previous slide, we have G is equal to big G, big M, small m all over R squared divided by m. Multiplying and dividing our small g, which is your gravitational field intensity, is given by big G times the big M all over R squared. Now, a simple exercise. From the example given above, can you calculate the gravitational field intensity? Yes, you should be. Now do that right now. In conclusion, I know we cannot confidently solve problems under gravitational force, define the gravitational field intensity, and as well solve problems relating to the gravitational field intensity. So next class we'll be seeing the reasons why G varies on the surface of the earth. Thank you for a wonderful time we have had, and bye for now.